Okay, to be honest with you, I don't know what title to put to this video, but I wanna ask Google why Rust is bad. So Rust programming has been a language that is coming into my feed, and I don't know anything about Rust. But I think it's time to share some ideas here, to do some research together, and read a little bit about why Rust programming language absolutely, positively sucks, or maybe not. So, as a contrary YouTuber, I asked why Rust is bad instead of why Rust is good, and it seems that this contrary takes works a lot for the algorithms. So that's why you have this. So let's see this YouTube channel.
Empowering everyone to build reliable and efficient software. Somebody's read the Rust Foundation's website. Yeah. Oh, okay. So, Rust.
You see how
I'm sure you're familiar with Rust by now, and if you're not, you've probably not had a
type of
conversation.
title works.
But Rust is a programming language empowering everyone to build reliable and efficient software. The idea is you get memory safety.
The slide were written by someone else and not shown to the speaker beforehand. This is insane. So let's read about Reddit. Let's start here. The Rust programming language is absolutely possibly sucks. And you read this? Rust programming language is absolutely positively sucks. I'm quite confident that I will get turned the thread for writing this post and called stupid, but I really don't care. I have to call a spade a spade. The emperor has no clothes. The Rust programming language is atrocious. It is horrible, and I wish it's painful and swift death. That's a very nice way to start a post about a specific language. Oh my gosh. I have been programming for well over 30 years. I'm quite good at it usually. Yeah. I have been told by many co-workers and managers that I'm super fast. Well, not in Rust. I have used quite a lot of languages over the years, though I am by far the most proficient in Java. I started working before Java even existed, so I programmed in C professional for 10 years too. Then switched to Java. I did this the same. I switched after 5 years in C, C++, I switched to C Sharp. And to be honest with you, if you read one of my videos, if you watch one of my videos from this week, I think you will see the transition it happened from Java C Sharp to C again in the next coming 10 years. And if you want to know why, you have to do one of my videos. Recall when I learned, I think it's this video, just to make sure I'm just... Oh my gosh, what I'm doing here. So if you want to know why, you have to read this video, The Future of Programming and Software Engineering. Okay? Let's continue here. So I programmed C professional for 10 years too, then switched to Java. I recall when I learned Java, I thought it was the great thing since sliced bread. Now here I am, forced to use Rust for a project at work. Is beyond painful. Of course, it's gonna be beyond painful when you spend so many years in Java. All the advice out there go slow. Take your time, etc. It's just unrealistic in real work environment when we have to actually accomplish a task for work. I need to write something that is highly multi-threaded and performant. I need what I need. It's not like I have the luxury to spend months building up to what I need from Rust. Right off the bat, as total Rust newbie, I'm hitting all kind of rough edges in Rust. For example, I'm trying to use Rust QLite. This is maybe a library to use SQL, something like that. It will be natural to stash db prepare statement in a thread local for reusing my multi-thread code. I can't pass the connections around because I need them in a C callback. Too much detail here, I know. So I have to be able to look them up. After banging my head against the wall for a full day, I'm just giving up on the thread locker approach because I simply can't get it work. Part of the problem is that I can't stash a prepare statement in the same thread local struct. at the connection from which they are created due to lifetime limitation. It also seems that you can really use two threads local, one for the connection and for the prepare statement either. If there is a way to do it, I can figure it out. Also, right off the bat, I'm having trouble with using async in trade functions. I tried to get it working with async trade create, but I'm failing there too. All in all, ROS is a nightmare. It is overly verbose, convoluted, hard to read, slow to compile, and lifetime really are a cool joke. Googling for what I need rather result in good answers. I'm truly convinced that all the people who claim ROS is great are either lying to themselves or others, or it is just a hobby for them. It should be this hard to learn a language. Rose feel like a major step back from Java. I had to run because there is so much people, cool eye drinkers. Okay, the statement of this guy is very clear. He was trying to get a task done and he couldn't with Rust. But he acknowledged that he couldn't do this task in Java because he switched to Rust. So somehow he realizes, or somehow he knew that the new task he had to get done with such performance was not or couldn't be done in Java. So then why learn Rust, right? So in that statement, somehow he saw some value on Rust, okay? But somehow he couldn't do the task he wanted to do in the way he wants to do on the first maybe 2 weeks, 3 months, or maybe 1 day, 2 days. So writing this type of pause, okay, is good. It's good that people share this type of ideas. But the problem is if you are an experienced developer, it doesn't matter how much experienced you are. There are some languages that take time. There are some languages that for understanding those languages you need more time, and you need a couple of weeks, sometimes a couple of months. Why? Because you are working in a language for so many years, like Java, which is an OOP language, object-oriented programming language, and these type of languages are very different from the one you're going to be working with. So some of the components, some of the buzzwords we work with it, but in my opinion, so you need to be very, very open-minded when you're going to start reading or learning a new programming language, because there are a lot of new concepts in English language that actually not all languages deal with the same type of conceptuality in the same way. Okay, let's see what people said about him. This was 2 years back though. Maybe the Rosa have been improved right off the bat. Okay, it's a total new hiding all kind of edges. So this guy is replying to him. I'm the maintainer of Rus Kulite. Oh, holy moly! So he got a response from the guy that works in this library. It is true that there are patterns you might be using to see SQLite use that don't translate well to Rust. This is for safety reasons. Statements borrow from the connections, which will definitely prevent the things you are trying to do. Instead, you should use .prepare each time or prepare cache. If it's a large complex query, it is fine. Thanks for the point to prepare cache. I will give that a look. I'll go confirm if that I can't do what I was trying to do. Seems very unfortunate, but good to know. The alternative will be, well, I think that we are just dealing with the more specificities about the languages, and the intent of this video is to understand why Rust is good. And I need to understand why Rust is good. Why Rust is good. This is, let's see.
Developers hate Rust. Despite Stack Overflow claiming Rust is the most loved language year after year, I haven't seen this much genuine hate for a programming language in a long time. It's gone so bad that merely mentioning Rust can trigger developers. But this hate isn't all unfounded, and it usually stems from 5 reasons. The first one being lack of job opportunities. To which I just have to say, the second reason developers hate Rust is the syntax. People say it's verbose, complex, and downright ugly. For comparison, let's take a look at the map method, which transforms a collection of one type to another type. The function signature in JavaScript is extremely simple.
Okay, so he just mentioned that Rust is hated by developers for the syntax. That shouldn't be, well, maybe it is a reason to hate a language. Because if it's not easy for you to write a program with a specific language, it's gonna be a reason to hate it. Definitely, it's gonna be a reason to hate it. Okay, but still, not because the syntax is hard, you cannot see benefit in specific languages. Languages, guys, is just a tool. I state this, and I discuss this a lot with my friends that are software engineers too. We have a set of tools, and you always want to use the same tool for everything. Within most cases, this is one of the only profession that you can use one single tool. Maybe let's call C# for many things. But if you are a cafeteria or something like that, or a doctor, or I don't know, whatever, there are not many tools that can be used for many things. And now I present to you a different tool, right? And of course, you are accused to use one specific tool for everything. And now you're going to start hating this because it's written in different ways. And when you start hating something and you don't have the open-minded on this profession, you start falling back. This is my personal opinion. Okay, this is my personal opinion. I don't know anything about Rust. Again, I don't know anything about Rust. This is the first time I'm dealing with these languages, and I'm going to read a lot about it, and I'm going to read it with you here in this YouTube channel. Okay, I just want to understand why people love it and why some people don't love it. But this, until now, on all this research we're doing, I haven't found a reason yet. For me, a syntax is not a reason to hate a language.
Whereas in Rust, it gets pretty complicated. We see generics, trait bounds, closures, the size trait, and this signature doesn't even include lifetimes. So yes, the Rust syntax is more verbose, more complex, and frankly more intimidating than a lot of other languages. But there are some...
Okay, I'm not sure if it's what it's going to say. For this type of constraints are built in software languages, in programming languages, for a specific reason. And it's for the reason for allowing developers, or for not allowing developers to make big problems, or make big mistakes. I'm sorry, apologize.
Good reasons for this. Rust is a statically typed language which favors explicitness in its type system. And it also has to model things like memory safety in its type system. The benefit of this is that it reduces ambiguity, which in turn reduces errors. The map function in JavaScript doesn't tell us what the type of the input parameter should be, or what the function returns, if anything. Developers have to dig into documentation to figure that out. This opens up the door for runtime errors, because a developer can literally pass in anything to this function. The map method in Rust, on the other hand, tells us exactly what it expects as input and what it returns as output. The code documents itself, and developers are required to follow this function's contract, otherwise they'll get a compile time error. By favoring explicit syntax and having a strong type system, Rust ensures your code is predictable, consistent, easier to refactor, debug, and maintain. It's also worth pointing out that Rust is constantly evolving, and improvements are being added to make the language, but I encourage you to give Rust a try and experience that warm fuzzy feeling you get when you successfully compile a program and know that it's basically going to work how you expect at runtime. The third reason developers hate Rust is because they say there are better languages out there. First of all, we have C and C++, which are both...
Okay, maybe this is just a statement that the guy made to make the point of the video. But you don't hate the programming languages because there are other better. It's like hating a tool because you have been using a different one for many years. That doesn't make any sense.
Low level and performant. If you're looking for simplicity, you can go with C. And if you're looking for a language that's object-oriented, has modern features, and a mature ecosystem, then you can go with C++. Not to mention that both C and C++ are established, widely used languages with plenty of job opportunities. On the other hand, you have Go, a language that's laser-focused on simplicity. Great for rapid development, and with an excellent concurrency model, it's especially great for building network services, such as web servers, APIs, and microservices. It's also great for CLI tools and automation scripts, and there are plenty open Go job positions. And then, of course, we have Zig, a language that also focuses on simplicity. In fact, their tagline is focus on debugging your application.
I haven't heard about this. What is the other language? Zip?
A language that also great for CLI tools, Go. A language that's laser focused on simplicity, great for rapid development, and with an excellent concurrency model, it's especially great for building network services, such as web servers, APIs, and microservices. It's also great for CLI tools and automation scripts, and there are plenty open Go job positions. And then of course we have Zig, a language
Zig. Oh, I haven't heard about this.
that also focuses on simplicity. In fact, their tagline and comes with a pattern tool for us to extremely high level of element and then deallocate that array. This is why we're seeing systems, Wind, other embedded devices, and where like cloud infrastructure to them. In Rust, if we tried to do the same thing, we would get a compile time error because the ownership rules would prevent us from making this fatal mistake. This is why we're seeing Rust get adopted for critical software like cloud infrastructure at AWS, the world's largest operating systems, Windows, Linux, and Android, and mission critical software in the aerospace industry, automotive industry, and other embedded devices. For these use cases, Rust is proving to be an
nice. This is a when you see this type of languages being used in such widely used systems, it has something.
excellent tool. The fourth reason developers hate Rust is because they either think there's too much drama or too much hype. I get YouTube comments all the time saying Rust is useless, it's overhyped, it's gonna die out soon, etc. And look, maybe you don't have a good use case for Rust, or maybe somebody at work is forcing you to use Rust against your will. And despite seeing a clear benefit, you see all these people online preaching the gospel of Rust. As a member of the Rust Evangelism Strike Force, I get it, sometimes we could be a little much. Everyone is entitled to their opinion, but the numbers and success stories don't lie. Rust's momentum is continuing. 1 million new Rust developers joined the community over the last 12 months. Rust subreddit has now surpassed the C++ subreddit, and Rust continues to be voted the most loved / most admired language year after year. And we continue to see
On this graph. Programming languages ranking. Let's see how the ranking show up today. Well, we don't have even Rust in the first 10. Red Monk, where this.
continues to be voted the most loved / most admired language year after year. And we continue to see industry adoption by tech giants like Microsoft, AWS, and Google. So is the hype real? In my completely unbiased opinion, yeah, Rust might be a little overhyped, but the hype is certainly real. But don't take my word for it. Look at the numbers, look at the success stories, and try it out yourself.
This is very important. You shouldn't go for all the hype, okay? You shouldn't go and follow and learn a new language because it's overhyped or you're listening to a friend that is being used. You should learn a language because you think it's going to be useful for what you have, of what you set of skills. Okay, if you're working a backend side, for example, and you think that you need to understand how super performant programming backend system has to be done, maybe you need to use Rust. Okay, if not, maybe you don't know. If you are in the web side, in the front end side, or as a full stack developer, maybe with just a simple Node.js backend service and a couple of JavaScript on the front end, it would be enough for you. So adding Rust to your skill set, maybe it's not necessary. So what I'm trying to tell you is the next skill you're going to get, the next skill you're going to pursue has to mean something for your skill set. Okay, has to mean something for you. Maybe you want to use it just for fun, maybe. Okay, but it's different when you're going to learn a language for fun, and it's different when you're going to really learn a language. It's very different. You have to follow different, in my opinion, you have to follow different approaches. Okay?
On the other hand, some developers hate Rust because of the drama. It's no secret that the Rust Foundation has had its share of controversies in general. Issues. As a result of these specific issues, some Rust entire channel dedicated to Rust, I definitely have some thoughts on this. In general, I think the drama is a bit overblown. I do genuinely believe that the Rust Foundation is trying to do the right thing. And even though they made mistakes, they did also respond to the community's feedback and actually mean it. And Rust is a low-level language which forces you to think about how things are laid out in memory. And Rust has a pretty complicated and unique type system. Things like the ownership and borrowing system, traits and generics, and macros, which take a considerable amount of time and effort to learn. The second way Rust is hard is that it's hard to read and write. Again, it has a pretty complicated type system and verbose syntax. You have to deal with multiple string types, smart pointers, lifetime annotations. I mean, you can't even write a linked list without having a mental breakdown. In addition to the type system and syntax, there's also the borrow checker. Dealing with compile time errors all the time can be very frustrating and definitely slows down productivity. In fact, according to the 2023 Rust Community Survey, the biggest reason preventing people...
This is true. My career, I have a bachelor degree in computer science, and my 5 years of the bachelor I spent writing C++. And it was very hard for me to, and not even for me, for all of my friends, learning programming with the builder and trying to figure out where the code issue was. It was very hard. I remember this was one of the hardest things for us in our career. It was very hard. One of the reasons many of us started jumping to different languages that were more productive. Okay, still C++ and C has its own benefits. Okay, even though if it's hard. Okay.
From learning Rust is its difficulty. But honestly, Rust is not the problem. Don't blame a perfectly designed language on a skill issue. If you wanted something easy, then learn a language that's made for 5-year-olds, like Go. Jokes aside, I know this is a very valid concern, which is exactly why I created Let's Get Rusty in the first place, to simplify Rust education and make it...
So, okay, let's find another. So this guy has a program, a video.
NVIDIA,
let's see, the popular, what can you build in Rust? Getting started with Rust, all Rust features playing. Okay, let's give it a try on this one.
If you've ever struggled to understand Rust's features or how they work together, this video is for you. Rust has many unbelievably genius features, but these features aren't exactly unique to Rust. In fact, Rust deliberately borrows these great features from many other languages and combines them into a single masterpiece. Understanding where Rust's most important features come from and how Rust has built on top of them is critical to use Rust effectively. So in this video, I'll explain Rust's most popular features, how other languages like C++, Haskell, and JavaScript influence them, and how Rust combined those features and built on top of them to become the most loved language of our time. Note that these features are sorted by complexity, so stick around till the end for Rust's most advanced features. This video is part of a series for the upcoming official launch of my Rust Developer Bootcamp, the all-in-one Rust learning program you've all been asking for. The exact official launch date will be determined very soon. To join the waitlist, pause this video and level language abstractions.
So we have some, let's review this video where we see some features explained about Rust. I want to understand what really Rust has in difference than other languages. Zero-cost abstractions, generics, iterators, templates, collections, and classes.
Generics and collections should not impose any runtime overhead or performance penalties compared to code using low-level abstractions like loops and counters. In this C++ example, we create a vector of integers and then use a for loop to find the greatest...
Okay, this is C++. So we create a vector. So we are finding the maximum here in this side. So we in the max element. So we, okay.
Element in the vector. In this example,
we show the element at the end.
We have to do loop initialization, condition checking, and element comparison, making it less readable and more prone to errors. By using the iterator abstraction, the code becomes a lot simpler. Now we just have to call the max element function. The iterator abstraction encapsulates iteration and comparison logic, making the code cleaner, more concise, and less error prone without sacrificing performance. Here's how we would write the same code in Rust. First, we turn the vector into an iterator by calling the iter method, and then we find the greatest element by calling the max method. In this example, we're actually using a few zero-cost abstractions in Rust. The first one being the iterator abstraction, the second one is the option enum, and the third is pattern matching. branching. The beautiful thing about Rust is that it builds on top of the zero-cost abstraction principle by further emphasizing memory safety and thread safety. Going back to...
Which is a very great point, right? It's a huge point. When you design this system with these programming languages to be safe, is important when you're developing critical systems.
To the C++ example, if we were to call the max element function with an empty vector, it would lead to undefined behavior. In Rust, on the other hand, the max method returns an option type. So if we were to call it on an empty vector, it would simply return the none variant. The option type forces us to check whether the return type is the some variant or the none variant, which makes our code a lot more robust while preserving blazingly fast performance. In other languages like Python, iterators are not a zero-cost abstraction. Python requires additional runtime checks to ensure the integrity of the
zero-cost abstraction
iteration process, because collections can change in size or structure during iteration. Systems programming languages like Rust can't afford this type of performance drag. Next, let's talk about one of Rust's most fundamental features, the ownership model. Ownership is actually based on the resource
So we have the first advantage with this zero-cost abstraction. And this is very important because I know, you know, and we know that a lot of languages deal with the data types in different ways. Okay, so sometimes a hash map is just a static dynamic, a dynamic array with inside a static array inside with a bit set, which is, as you can see, there is different ways of every languages deal with this type of abstractions. And for example, if you are going to find, I was seeing this video last week about how you can improve the algorithm performance just by changing the data types you use in your application. But the data types the video was using Python, and you were basically trying to analyze the window of a string of characters that where those specific chars were not repeatedly. And the initial algorithm was using a hash map, and the other algorithm was using a big set, which is very different. But you need to you need to understand these languages in deeply, so you can see the difference on how these abstractions are programmed by the language designer, right? So I think it's very
initialization design.
I think this is very important.
And pattern in C++. The RAII pattern states that resources like allocated memory, file handles, and database connections should be tied to object lifetimes. When an object is created, it acquires resources, and when the object is destroyed, those resources are released. Here's a C++ example of opening a database connection without using the RAII pattern. First, we define the DB and DB name variable. Then we open a database connection, check to make sure that DB is not a null pointer, perform some database operations, and finally close the connection. Think about what would happen if we didn't close the database connection. We would create what's known as a resource leak. Now, I know this is a simple code example, but imagine if there were hundreds of lines of code between the code opening the connection and the code that was supposed to close the connection. It's very easy for a developer to forget releasing the resource, which is why it happens all the time. Let's see what this code would look like if we use the RAII pattern. In this example, we've created a class called database connection. In the constructor, we acquire the resource, which in this case is a database connection. And then in the destructor, we release the resource, which in this case means closing the database connection. Then in main, we simply create an instance of database connection, passing in the database name. We then make sure there's a database connection and perform our database operations. Connection is a stack variable, so it will be deallocated at the end of the main function. When it's deallocated, its destructor is called and the database connection is closed. As you can see, this pattern leads to convenient and reliable resource management, cleaner and more readable code, and eliminates resource leaks. In fact, this pattern is so useful that Rust integrated it directly into the language. So you don't have to remember to use the pattern. The compiler will simply do it for you by enforcing a set of rules known as the ownership rules. The rules are actually really simple. The first one is that each value in Rust has a variable that's called its owner. There can only be one owner of a value at a given time, and when that owner goes out of scope, the value is dropped. Here's how the database example would look like in Rust.
I think this video is good, guys. I will put the link below here so you can see the video. I think this. So I like how this guy compares the same piece of code in different languages, so you can see the benefit. I really love this, and I think it's very useful for us developers to understand the differences. Okay.
We have a struct called database connection, which holds a connection object. When a new database connection instance is created, we acquire a database connection and store it inside the struct. In main, we can create a new instance of the database connection struct and pass in our database name, and then perform any database operations we want. Unlike the C++ example, there is no destructor which releases the database connection. Instead, the connection variable will go out of scope at the end of main, and the database connection instance will be dropped. And any values database connection is holding will also be dropped. This just happens automatically for you.
And this is something that I was discussing with a friend this week. If you want to understand how programming language really benefits what you're doing or benefits you on your systems or on the type of application you're building, you need to understand this language and how the compiler works along with the language. And most people don't understand this. Okay, if you're a C# developer, for example, you need to understand how the GIT, the type of compilers that you have in the C# framework, in the .NET framework works. So you can better understand how you make your code better.
Like magic. But in reality, the Rust compiler is simply following the ownership rules, which as you can see leads to very simple and clean code that avoids resource leaks. Rust further builds on top of the ownership rules by combining them with the borrowing rules. The borrowing rules state that at any given time, you can either have one mutable reference or any number of immutable references, and references must always be valid. Going back to the Rust example, you can see that
So if you know what mutability talks about, mutable is immutable. Mutable.
Yeah, but
Mommy, you have to wait 1 second, okay? Let me finish this video. Give me just 10 minutes, okay?
it does.
Okay.
Un momento, solo quiero ver.
Okay.
and references must always be valid. Going back to the Rust example, you can see that we can create multiple immutable references without any problem. But if we introduce one mutable reference, we would get a compile time error because we're mixing immutable and mutable references, which is against the borrowing rules. Now you might be thinking, why are these rules necessary? By enforcing that resources either have multiple readers or a single writer, Rust prevents an entire class of bugs known as data races. And by enforcing that references are valid, Rust prevents null pointer dereferencing. Ownership and borrowing are concepts that many beginners and even intermediates get stuck on or don't have a full understanding of. That's why I always recommend doing exercises or projects focused on these two subjects. In the Rust Developer Bootcamp, which ownership features types, functional language, big data types, or ADTs are a type system concept commonly found in functional languages. They allow us to create composite types using sum types and product types. Sum types, also known as variant types, let us define a type that could be one of several variants. For example, we can define a shape type, which could either be a circle, rectangle, or triangle. Product types, on the other hand, are similar to structures in C. They allow us to bundle multiple types together. For example, here we have a person type composed of a string, an unsigned 32-bit integer, and a floating point number. ADTs are useful because they allow us to model complex data structures and enforce constraints on data at the type level, which can help catch errors at compile time. Let's look at how ADTs are implemented in Haskell. Here we have an employee data type. This is a sum type consisting of two variants, manager and worker. Each variant can hold different types and amounts of data. A manager has a name and a list of subordinates, while a worker has a name and a single manager. Here's the same example implemented in Rust. In Rust, ADTs are implemented through enums and structs. Enums are sum types and structs are product types. In this example, employee is a sum type, so we're using an enum. While the concept of ADTs is similar between Rust and Haskell, there are some differences. Rust integrates ADTs into an imperative programming style, unlike Haskell, which is purely functional. Also, Rust combines ADTs with other language features like pattern matching, lifetimes matches like Haskell. In this example, we're using the match expression to pattern match on an instance of the employee enum, which allows us to handle each variant differently. Pattern matching in Rust also enforces exhaustiveness, which means all variants of an enum must be handled, preventing potential runtime errors. Next, let's talk about one of the pillars of object-oriented programming, polymorphism. Polymorphism is the ability of an object or function to take on multiple forms or behave differently based on the context in which it is used. Some languages implement polymorphism through inheritance, but Rust takes a different approach. In Rust, polymorphism is implemented with traits and generics. Traits define a set of functions and methods that types can implement, similar to interfaces in other languages. In this example, we have a trait called shape with one method called area. We can then implement the trait on the rectangle struct and the circle struct, which calculates area differently. Note that types can implement multiple traits, and traits can have default implementations for functions and methods. Generics, on the other hand, enables us to write code that is abstracted over types, which leads to reusable and efficient code. For example, here we have a function called printArea, which takes the generic argument shape. In Rust, generics can be bound by traits. For example, in this case, the generic t can be any type that implements the shape trait. In main, we create an instance of rectangle and pass it to printArea. We then create an instance of circle and pass it to printArea. Our function can accept both arguments because rectangle and circle implement the shape trait. The trait system in Rust has its roots in Haskell's type classes, which provide shared behaviors for types. But Rust builds on top of the concept of type classes by incorporating ownership, borrowing, and lifetimes into the trait system, which are central to Rust's memory safety guarantees. Rust also supports dynamic dispatch with trait objects. A trait object allows you to treat different types that implement the same trait as interchangeable. For example, here we've created a vector of shape trait objects that stores a rectangle and circle. The trait system in Rust has several advantages over classical inheritance. It allows for more flexible code design and composition. Multiple types can independently implement the same trait, enabling flexible composition.
Well, composition and flexibility, if you understand this concept really well, okay, and that's what this guy on the beginning was having so many problems at the beginning. So if you're used to Java, C# type of languages, you have to change. You're dealing a lot with classes and interfaces, okay, and here everything changed, okay. So you have traits to apply, so to traits and generics to create polymorphism, and to have objects or components that can implement the same behavior in different ways, which is very different actually.
Without relying on strict inheritance hierarchies. Traits are also non-invasive. They allow behavior to be added to types without modifying their original implementation or inheritance hierarchy. Traits also avoid the fragile base class problem, where modifications to a base class can unintentionally impact derived classes. Lastly, Rust's trait system uses static dispatch by default, enabling efficient code generation. Next, let's talk about a feature Rust stole from JavaScript: the async await syntax for asynchronous programming. Asynchronous programming is a programming paradigm
this is not used in JavaScript, so it's also used in C# actually.
Allows tasks to run independently and concurrently without blocking the execution of the main program. In JavaScript, promises provide a way to handle asynchronous operations. A promise is an object that wraps the result of an asynchronous operation, allowing you to attach callbacks to handle the success or failure of the operation. In this example, we have a function called getUserData, which takes a user ID. Inside the function, we use fetch to make an API call. Because this is an asynchronous operation, fetch will return a promise. We can call the then method on the promise and pass in a callback, which would be called if the operation succeeds. And we can call the catch method and pass in another callback, which will be called if the operation fails.
It's incredible when you are used to a simple language how you can read these lines and you can understand everything. It's amazing. It's really amazing. And when you are dealing with a different language, so I read this piece of code and I understood what it was doing in just 1 second.
Now this code looks pretty readable, but imagine if we made the example slightly more complex. Our function is now called getPostData. It takes a user ID and a post ID. What we want this function to return is the user data, the post data, and the comments on that post. Let's imagine that in order to do this, we had to make 3 API calls that were dependent on each other. First, we have to get the user data. Then we have to get the post data. And finally, we have to get the post comments. Only then do we have all the data we need to return. As you can see, using promises can lead to deeply nested code, which is not very readable. Let's see what this example would look like using the async await syntax. The async await syntax is a language feature that simplifies asynchronous programming by allowing developers to write asynchronous code that looks like synchronous code, which makes it a lot more readable. The first change we made is added the async keyword before our function definition. Then inside the function, we use the await keyword before every asynchronous call. And for error handling, we use a try catch block. As you can see, the code is a lot more readable, but there's nothing special going on here. In fact, async await is syntactic sugar for working with promises. Rust adopted a similar approach to asynchronous.
Okay, let's stop here. I want to read this code better. So we have an async function, get post data. Okay. User and pause. Okay, that has a result something and it pass user pause and a vector of comment and also an error variable. Okay, you create a client, a request. This seems to be like the client request to create the client actually to make the request, the user, and here you make so user pause comment. What this code is very readable though.
Programming with a slightly different syntax. Just like with JavaScript, the async keyword is added before our function definition. Inside the function, we add .await to every asynchronous call, and we use the question mark operator to propagate errors instead of a try catch block. Just like with JavaScript, the async await syntax in Rust is syntactic sugar for working with futures, which are similar to promises in JavaScript. Now, even though the async await syntax looks similar in JavaScript and Rust, there are some big differences. One difference is that Rust's async await model incorporates the zero-cost abstractions principle. In Rust, futures are designed to be lazy, meaning they don't start executing until explicitly polled by awaiting them. This means futures can be scheduled, composed, and combined with other futures without incurring unnecessary overhead. Futures are designed this way because of Rust's general principle of being explicit, which means favoring clear and unambiguous code that requires developers to be explicit about their intentions. In contrast, promises in JavaScript are eager, meaning that they start executing immediately upon creation. When a promise is created, it initiates the asynchronous operation right away, even if the current on-blocking of operations in parallel by utilizing alt-dead JavaScript, even if the promise is not awaited yet. This can result in potentially unnecessary work and resource utilization. Another difference is that JavaScript is single-threaded, which means concurrent operations aren't truly happening in parallel. Instead, JavaScript uses a non-blocking event loop, which can handle multiple operations almost at the same time, giving the illusion of parallelism. Rust, on the other hand, offers true parallelism. It can run concurrent operations in parallel by utilizing multiple threads. Next, let's talk about one of Rust's most powerful.
Okay, this statement is very important. Okay, and I think I need to read a little bit about it. Okay, but it's very important.
Parallel by utilizing multiple threads. Dive into macros, we need to understand metaprogramming. Metaprogramming is a programming technique that allows a program to manipulate or generate code during compile time or runtime. Macros are a language feature that allow developers to define custom syntax and perform code generation or code transformation. They enable metaprogramming by providing a way to write code that generates or modifies other code during compilation. Here's an example of a declarative macro in Rust called map, which is used for creating hash maps. Declarative macros are defined using the macro rules keyword. These macros take code as input, match it against a set of patterns, and generate new code based on those patterns at compile time. The first pattern matches when the macro is invoked with two type expressions
Yes, let's move
separated
forward
by
a little
comma,
bit. I want to
the
understand
variables
what
from the
is
surrounding code. In
the
this
last
talk
feature.
about a feature Rust stole from the world's most popular web framework. Before we get to that, keep in mind that real camp, which allows JavaScript to break beyond the confines of the
What
browser.
Rust
This
stole
led
from
to an
Node.js?
explosion of JavaScript-based backend applications. Alongside Node.js, RAII also created Node Package Manager, or NPM for short, giving developers a powerful tool to manage dependencies and share code created, serving as the central hub for hosting and discovering public packages. Rust took this idea and ran with it by creating Cargo and crates.io. Cargo is Rust's official build system and package manager. It handles many tasks such as building code, downloading and compiling libraries, and managing Rust versions and configurations. These operations can be performed with simple CLI commands like cargo build, cargo test, and cargo run, similar to npm commands like npm install, npm test, and npm start. In Node.js applications, dependencies are listed in a file called package.json. Similarly, in Rust, dependencies are listed in a file called cargo.toml. In Node, public dependencies are pulled from npmjs.com, and in Rust, public dependencies are pulled from crates.io. Cargo and crates.io enable reliable dependency management, streamlined project building, integrated testing, and simple package distribution, which are features the systems programming space has lacked. This makes development so much easier that it might be my favorite Rust feature. All these features make Rust the incredible language that it is, but understanding how each feature works together and how to use them in practice can be very difficult. That's why I created the Rust developer.
So, yeah, I think this guy is very good on Rust. So if you want to learn Rust, you should follow him. For now, I think we have the most important features that I think we need to dig further. I'm gonna dig here. I'm gonna do it here in this video. But I think Rust is just a language. It's another language that can be used for many things, and it seems that can be used for software that needs a lot of performance, and I need to be used for developers that are very good, because you need to understand a lot of concept, and you need to really understand how this type of languages benefit with the machine you're building in. So up to today, I think my take on these really on these few minutes of analysis on Rust. Okay, learn Rust if you think it's going to be useful for you. Learn Rust if you think you will need it in the future. Okay, you can play with it, you can research a little bit about it, as we're doing now, just for fun, just for understanding the difference. But right now, for example, I don't see Rust in my skill set. Okay, even though I'm trying to understand what Rust is and why it's so popularized and so hyped, I don't see myself looking at it right now. And my opinion on this is that you as a developer, you as an engineer, you need to understand what type of tool you need to get good at, and you need to understand what type of tool you don't need to get good at. Okay, and you cannot learn all the languages. Okay, or you can learn all of them, maybe a few of them or a couple of them, but you can be good at all of them. So you need to decide that. And the other take on this video is that Rust it seems to be a very good languages for you to use if you are working in high scale and high performance teams that cares a lot about performance, mostly on the backend side. Okay, so see you in the next video. I hope this video give you some insight. I'm learning a lot with you here. So see you in the next video. Bye bye.